Lesson Master 4.2, the rest of it, 4, 5, and number 7. Number 4 says a sector in a circle with a central angle 7 pi over 2 has an area of 14 pi meters squared. I feel like I do want to clarify that a sector is, if I was to have, it's kind of like the area of a slice of pizza. The sector is the whole piece like that. So in my circle, I have a central angle of 7 pi over 2, and the area is 14 pi meters squared. So my area, I'm going to use the formula that I have up above, 14 pi equals my fraction of the circle, which is my 7 pi over 12, all out of 2 pi, times the area of my circle, which would be pi r squared. And I don't know what the radius is. That's what I'm trying to find. So all I've done is I've used this formula for area of a sector is 14 pi, area is 14 pi, fraction of the circle, 7 pi over 12, out of 2 pi, area of the circle, pi r squared. So now I've just got to clean all this up. So I still have 14 pi equals 7 pi divided by 12 times 1 over 2 pi. Remember, when you're dividing, you multiply by the reciprocal, times pi r squared. Well, these pi's cancel, and I'm left with 14 pi equals 7 pi r squared. That's 7 pi r squared all over 12 times 2 is 24. Well, since I'm trying to solve for the radius, I need to get rid of 7 pi over 24. So I'm going to multiply by 24 over 7 pi. That will get my 24s to cancel and my 7 pi's to cancel, which means I have to do the same thing on this side, 24 over 7 pi. And let's see, 14 pi divided by 7 pi is simply 2. And I'm left with 48 equals r squared. To solve for r, I take the square root. Normally, I would need plus or minus, but because it's radius, I only need the positive square root of 48. That's my exact answer. That means no estimate. I could reduce this radical. The square root of 48 has a perfect square in it, 16. So I can rewrite this as 16 times 3, which then gives me 4 times the square root of 3 is my radius. That is an exact answer for the radius for number 4. Okay, let's look at number 5. James needs to replace the glass of the speedometer on his old car. If the needle can maximally rotate 5 pi over 12, so that means this entire angle here is 5 pi over 12, find the area of the glass that James needs. Well, I would think that James would want the glass to cover all of this, like this whole thing here. So I'm thinking we're going to use 8 as the radius, not just the 4. I would think we'd want the 8. So the area of this sector is going to be, we don't know that part, the fraction of the circle is 5 pi over 12 divided by 2 pi times the area of the circle is pi. The radius is 8 times 8 squared. Let's go ahead and simplify that. 5 pi over 12 times 1 over 2 pi. Dividing means multiplying by the reciprocal, times pi times 64. I know these pi's cancel. And I'm thinking it didn't say exact, so I'm just going to go ahead and put this into my calculator. I'm going to put the numerator in. So I'm going to take 5 times pi times 64, and I get 1005 approximately. And I'm going to hit divided by 12 times 2 is 24. And I get the area is approximately 41.88. Let's just say 89. And what is the centimeters squared? All right, number 7. Caitlin watched her son Dizzy ride a horse 22 feet from the center of the merry-go-round. So I'm thinking this right here is 22 feet. Dizzy completed 1 revolution in 45 seconds. How far did Dizzy travel in 1 revolution? Well, 1 revolution of a circle is the circumference, because Dizzy's going to travel around 1 time. That's the circumference. So circumference equals 2 times pi times 22, which is 44 pi. I could leave it like that. If I want to put in my calculator, 44 times pi, I can say approximately 138.23, and this is feet. How far did Dizzy travel in 1 minute? Well, I've got to figure out every time Dizzy goes around, it's 44 pi. So how many revolutions are in 1 minute? Well, if it's 1 revolution in 45 seconds, and 45 seconds is 3/4 of an hour, and 0.75. I didn't mean an hour, I meant a minute, and 0.75 minutes. Or, you know what I could do? I can leave it as seconds. 45 seconds. How much of a revolution do I do in 60 seconds? Think of it that way. 1 revolution in 45 seconds is how many revolutions in 60 seconds? 45x equals 60. So x equals 1.3 repeating. So I'm going to go 1 1/3 revolutions times my 44 pi, because 44 pi is 1 revolution. So I'm just going to multiply that answer out of my calculator by 44 pi, and I get approximately 184.31 feet. Caitlin noted that her son started at the easternmost point of the merry-go-round. So that means he started right here. If the merry-go-round rotates counterclockwise, which would be this direction here, and the ride lasts 4 minutes, sketch the position of her son when the ride ended. All right, so if 1 revolution is in 45 seconds, how many revolutions would there be in 240 seconds? Again, I cross multiply. 45x equals 240. So x equals, let's say, 240 divided by 45, and I get 5 1/3, which means Dizzy went around 5 times 1, 2, 3, 4, 5, and then 1/3 would be, I don't know, right about there. This is the position that he'd be in. I'll just put like a star right there.